Let's look at another question. A bag contains 2 rupee coins and 5 rupee coins. There are a total of 30 coins worth 90 rupees. How many 5 rupee coins are there? There are a few ways of solving this question. Let's look at the traditional approach. One way you typically do this is to say, let there be A 2 rupee coins and B 5 rupee coins. You can write an equation for the number of coins. There will be A plus B is equal to 30. You can also write another equation for the total value of the coins. A coins would be worth 2A rupees. The B coins would be worth 5A rupees, and their total worth is 90 rupees. Now you have two variables, two equations. Linear simultaneous equations. You know how to solve this. This would be one way of going about it. Now, the number line approach that we learnt can be applied here. What does that look like? You can just look at the 30 coins worth 90 rupees and say that the bag contains the coins in the bag, they average 3 rupees per coin, right? And you can put the 3 as the weighted average of 2 and 5. There are two things being mixed. The first type of coin has 2 rupees per coin. The second type is 5 rupees per coin. The mixture has 3 rupees per coin. So that's a distance ratio of 1:2. That's a quantity ratio of 2:1. Because you have a total of 30 coins, that will be 22 rupee coins and 10 5 rupee coins. As you can clearly see, the total value is 40 plus 50 is equal to 90 rupees. That's the second approach, the number line. Now, I want to discuss a third way of dealing with mixtures. That would be using replacement. Let's look at how that is done. Now, you have two things that, so you have 2 rupee coins and you have 5 rupee coins, and two conditions that should be satisfied. One is that the number of coins will be 30, and the second is that the value of the coins is 90. So the approach is to first fix any one of them. Ideally the number of coins. Let's fix this first, and then look at different combinations and finally figure out a combination that leads to 90 rupees as the total value. So what I'm trying to say is, if you had all 2 rupee coins, right? You have 30 coins and that's not going to change. I'm saying, what if all of them were 2 rupee coins? This would have been worth 60 rupees. Now, you have 30 coins. What you need to do at this point is remove a 2 rupee coin and put a 5 rupee coin in its place. Right? Replace. What happens then is that you will effectively gain 3 rupees. You're removing a 2 rupee coin and putting a 5 rupee coin in its place. So the number of coins will remain at 30 coins. But the total value is going to increase by 3. Now the question is basically, how can you get from 60 rupees to 90 rupees using these replacements? How many such replacements would you need? So you need to increase the value by 30 rupees, and the increase for each replacement is 3 rupees. So clearly you need 10 replacements. This is the approach. 10 replacements would mean that there are 22 rupee coins still left, and the replaced coins will all be 5 rupee coins. So there will be 10 5 rupee coins. That is how you figure out the composition of a mixture using replacements. Does this replacement approach have an advantage over the number line approach? It does in certain situations. I can demonstrate that with an example. I'm just going to slightly modify the same question. It looks like this now. Same question almost. 2 rupee coins and 5 rupee coins are there. 30 coins worth 78 rupees. How many 5 rupee coins are there? Here you can say that let's start with the starting configuration of only 2 rupee coins. That would be 60 rupees. But from 60 you need to get up to 78 That's an increase of 18. And each replacement increases the net value in the bag by 3 rupees. So that's going to be 6 replacements. So that's going to be 24 twos and 6 fives. Still easy, right? But if you had to do this question, this modified question with a number line, the method is still logically sound. It can be used to get the right answer, but the calculation is not very easy because you'll have to put a 2 here and a 5 here. You'll have to put 78 by 30 is 2.6 here, and then you have to work with this 0.6 is to 2.4, and depending on the kind of numbers, so this is actually not too bad. You can say it's 24/6, but depending on the kind of numbers you get, let's say you didn't have a nice round number that ends in 0, the number line method could end up being more strenuous calculations if you don't have easy numbers. This is an example where whatever numbers were given, the replacement approach would actually be more efficient. We can again look at one more modified example. Let's see. I've tweaked the numbers again. Same question, just slightly different numbers. 2 rupee and 5 rupee coin mixture, 73 coins worth 115 rupees. Replacement approach, I would say all twos would be 146. You need to go up to 158. That's an increase of 12. Replacement is plus 3 rupees per replacement, so that'll be 4 replacements, and you will say that this is actually 69 into 2 and 4 into 5. Plain and simple. But if you had to use the number line, the problem starts here. You need 158 by 73 here. The method is logically sound, but this calculation is going to be painful. And even after you find this fraction, then finding this distance ratio would be more time consuming than using the replacement approach. This would give you 4 replacements very quickly, and you will get the answer much more easily.